Hello everyone, this is Dr. Ali Safar, Java Computer Programming Language. In this lesson, we will have a quick review on Java classes and objects. Basically, we will show you step by step on how to define classes with data and methods, as well as on how to create objects from these classes to access the data and the methods. So your first step is to create a class as you see on this picture. And the next step is that you create the object from this class to access the data that you have defined inside the class. Our lesson is divided into 6 steps. In the first step, we will show you by an example on how to define a class with public data, and the data is called instance variables. And the second step, we will show you how to create an object from this class and that you have created in step number 1, and we will show you how to access the public data. In step number 3, we will also show you how to define methods inside the classes and how to access these methods when you create the objects. Step number 4, we will show you how to initialize the instance variables inside the class by using a special method which is called a constructor. Then we will change the public data modifier from public. We will show you in step number 5 how to define variables as a private. And when you define the variables as a private, you are hiding the data inside the class. As a result, if you want to access the private data in step number 6, we will show you how to define special methods that are called getters and setters for the private instance variables. In the first step, we will show you how to define classes with public data, with public instance variables. We will depend on one example during the lesson, which is an implementation of a class that models a self-controlled circle. When we say self-controlled, it means it does all the related calculations, such as computing the area and computing the parameter from its radius. Before we start, we would like to see what are the calculations that we could have on area and parameter. So if we have a circle with radius, if we want to compute the area, then we multiply pi by radius square. Pi is constant and radius is the radius of the circle. And if we want to compute the parameter, the equation will be multiplying 2 by pi by radius. So what we need to define inside the class as data. As you notice that the circle has radius and has also a constant which is pi, but pi is constant, so we will define it inside the class as fixed number that cannot be changed. And then we will define radius as the only data instance variables for the class. So the class will look like the following. As you know that the class consists of data and methods. So this is the data, which is radius of type double, and it is the instance variable. And we are going to define 2 methods, which is the action on the radius. As we said that the circle will be self-controlled. That means it will compute its area and it will compute its parameter using the radius. And when we create the object from this class, all what we do, we tell the class, give us the area and give us the parameter. So we need 2 methods and we need 1 data which is the instance variable. In object-oriented programming, first you define the class and then you create an object from the class. As a rule in Java, every class should be defined in a separate file. So you cannot define 2 classes in a single file. So we will define a class called circle and we will save it in a file called circle.java. To define the class, you write public followed by class followed by the name of the class. And as a Java convention, programmers usually follow this. It is always the first letter of the label of the class should be in uppercase. So always the class name starts with uppercase. And then you put the curly brackets for the beginning and ending of the class. Now we will define the data inside the class, and then later we will show you how to define the methods inside the class. As I mentioned, that we need two data members, and they are the variables inside the class, the instance variables are called data members. One will be for the constant pi, and the other one will be for the variable radius. And after we define the data members, we will define the methods. Notice that the label for the constant pi all uppercase because we assume that this is a convention followed by Java programmers that all constants should be defined with uppercase. After defining the class, now we need to create an object from this class. So we will have another class for our main program, and from there we will create an object from this class. So this is the definition for our circle class, and now this is another file which is another class. We call it main class, and it has the main method inside it. So your program will start in this class. So basically at the moment we have two classes, one for circle and one for main class, but we will start in main class. So how to create an object from circle class? The syntax is as follows. First, you type the class name, followed by a variable name, and later we will call it reference, equal, and then you write the new command, which is the command that will create the object for you, followed by the name of the class with round brackets. But this is in fact not the name of the class. This is a special method which is called a constructor. It is used to initialize the instance variables inside the class. But for the moment, we are not going to use it to initialize the data inside. So we have a constructor by default provided by the system, and we don't need to write it down. We will come later and show you how to create a constructor to initialize the instance variable inside. At the moment, when we create an object, none of these data are initialized, except that pi will have this initial value, but radius is not initialized yet. After you define or after you create the object, now you need to initialize the data inside. In other words, you need to access the data inside the object to initialize the data. And this is what we are going to do next. When we create the object, we don't have a radius inside. So the object is C1, and inside C1 we have the constant pi, and we have the variable radius. Now if I want to change the value of radius, or if I want to set a new value, you first write the name of the object, C1, and you write dot. So this is the dot that makes me go inside the object. We call it accessing. So if you want to access the method, or if you want to access data inside an object, you use dot. So when you write C1 dot radius, you are referring to the radius of the object. And when you say equal to 2.3, that means it's going to change it into 2.3. So here we are writing into the variable. Now if I want to read the data inside, you do the same. Now here I want to print. So I'm not going to change the radius, I'm going just to read it for printing. So again, you use the variable for the object, which is C1, and then you use dot and you write the variable name, the instance variable inside. So since the data inside circle, the instance variables, you define them as public, then from outside the class, which is another class, you are able to access them freely by using dot. So here in this class, you have changed radius. So radius was not changed inside the class, it was changed outside. And also you were able to see the radius inside from outside. Why? Because they are public. Now let's go to JGrasp and write these two classes and run the program to see how it works. Now we are in JGrasp. Let us first define the circle class. So we go new, and then we start typing by saying public class and then circle. Remember, C should be in uppercase, and then inside we will define the data members, and the data members are called instance variables. We are going to have two data members, one which will be for pi, public, final, double, pi, which is equal to 3.141592654. And the second data member, the instance variable, will be for the radius. And as you see that the radius is not initialized yet. And below here, we will define the methods later. So we have a class that has only two data members, which is pi and radius, called instance variables. First, we need to save it. And remember that you have to save it with the same name as the class. And we are going to save it in our project called Shapes Classes. So we have now one class, which is called Circle. Now we need to create another class for the main program. So we will say File, New, Java, and here we will write public class, and we will call it main class. Or it is preferable that we relate it to Circle class, and I'm going to call it Circle app, because this is an application, a class that we will create objects for the classes inside it. And then inside we define the class. We will have the method public static void main args, and this is our method for the main class. And we have only one method inside. In the first step, we will create an object from Circle class, and the syntax will be as follows. First, you type the name of the class, which is Circle, and define a variable for it, which is a reference. I'm going to call it C1 equal, put the new command, which is the command responsible for creating the object, and then we put the constructor, and we don't have a constructor, so we will have empty constructor provided by the system called default constructor with empty input parameters. Now the object is ready and it has the data inside, but the data is not initialized. So first we need to set a new value for radius. So we will say set the radius to 2.3, and we do this by accessing the variable inside the class by saying C1 dot. Now when you say dot, it means you are going inside the class, and this is the object of that class, and you write radius and you write equal 2.3. In fact, you are initializing the radius of the object. Next, we want to read the value of radius inside by printing. So we will print the radius, and also we call it accessing. So we could access the data either for writing or reading. Now here we are writing, we are changing the radius. So if I want to print the value of the radius, so we need the radius as, we need to access the data inside the object, which is radius, by writing C1 dot radius. And here we are accessing the data for reading, and here we are accessing the data for writing. See, we are changing radius, but here we are not changing radius. So when we say we are accessing the data, it means we are using dot, the dot reference. We will save this file, and we will save it into the same project. And now we have two classes, one for Circle and one for Circle application. Now we need to run the program to see the structure of the object inside the memory. We will use the Canvas viewer. So we will go to Circle application and we will start the viewer canvas. Now here we have the canvas, and as you see in our main program, main method, we have only one object, which is C1. So we will create this object. Now the object is created. Now if I want to see the data inside the object, we drag it from left and we drag it inside. So this is now the structure of the object. And how did we find the structure? From the class. Because I know inside the class, which is the map, we have a variable pi, which is constant, sorry, we define it as constant, and we have a variable radius. It is the system initialized it to 0. Now when you move to the next step, in fact you are changing radius to 2.3. So notice that radius has changed to 2.3, and also when you print radius to the output screen, see, notice here the output screen, we are not changing the value inside, and the object is holding the data during the lifetime of the program. We will stop the canvas, and also I would like to show you that how we can also access pi from outside the class. Yes, so here if I want to print the value inside the class, the value of pi inside the class, we say system.out.println, and we will say the value of pi is, and then you can say c1.pi, because pi is public and radius is public. So you can use the dot reference to show it outside and read it from outside. So let us run the program now quickly, and as you see now it is printing the value of pi from inside the class. Later we will show you if we don't want to expose pi outside, if we want to make it inside the class only, then we need to define it as a private instead of public. After defining the data inside the class, let me show you how to define methods inside this class. You can look at the methods as a box. It has Java statements, a collection of Java statements, has input parameters called argument, and has a return value. So when this method receives an input, the Java statements will work on this input, and as a result will produce a return value. As a typical example on Java method inside a class, this is an example of a method. First, this is the collection of the Java statements. They are surrounded by curly brackets, and every method must have a header. It's called method header, and this will represent the title of the method. Now the title or the header consists of parts. First, they start with public, and if they don't start with public, then we will not be able to access them from outside. Next, we specify the return data type, because whenever a function or a method is returning a value, then we have to specify what is the data type of this return value. Coming next is the name of the method. For every method you have to give it a name, followed by the input parameters, which are the arguments listed between round brackets. Now how to specify these parts depends on what you write inside the method. So the first step, if you want to write a method, is you write the code inside. Just first specify what this method is doing. After you write the code, then you look into the code whether you need an input parameter or not. By looking at this code, it is finding the summation between two numbers, start and end. Notice that I is for the loop variable and sum is for finding the summation. So start and end should be given as an input to find the summation between any two numbers. And of course, this code is finding the sum, so it must return a value. So it must give us a result. So this is why at the end we write return, and the return value will be the variable sum inside the method. Now by looking at the return value is sum, and sum is defined as an integer, so therefore the return type should be an integer. So the return type and the return value, both of them should be the same type. Now let us get back to our circle example. Let me show you how to define two methods, one for computing the area and one for computing the perimeter. First, how to compute the area. To compute the area, it is simply a single line of equation, and this will be the code that we need to include inside the method. So we need to surround it by curly brackets. By looking at this code, notice that the result is saved into area. So the function of this method is to compute the area, so it must return the result. Imagine you are the method, and I ask you to compute the area. After you compute the area, you never give me the answer back. In this case, what's the point to ask you to compute the area? Similarly for the method. The function of this method is to compute the area. So it must return the result back. Otherwise, it is pointless to define it to compute the area. By looking at the equation, the result of the calculation is saved into area. And this would represent the return value. So we say inside the method return area. Then we need to find the header of this method. And remember that the header of this method, we start by typing public, followed by the data type of the return value, followed by a name, and followed by the input parameters between round brackets. Since we are returning an area is defined as double, then the return value or the return data type of this method should be double. Now you need to choose a suitable name that represents the calculation of the area, and I'm going to call it get area. Now how to specify if this method needs an input or not? By looking at the code inside. To find the area, we need pi, and pi is already defined inside the class. And it needs radius, and also radius is defined inside the class. So to find the area, all the data available inside, so we don't need any data from outside, so the input will be empty. So for this method, we don't have any input for the method, but it needs a return value which is double. Next, we need to define the method for computing the parameter. So we need to specify what is the code we should include inside the method, and the code inside the method is simply an equation for computing the parameter, which is equal to times pi times radius, and the result is saved into a variable called parameter, which is double. You surround this line by curly bracket, and this will represent the body of the method. Since we have a line of calculation, most probably it returns a value, and the return value is in the result of the calculation, which is saved into parameter. So we write return parameter. So notice parameter is defined as double, so the return value should be a double data type. Like what we did before, we start the header of the method by typing public, and then we need to specify the data type of the return value. Next is the name of the method. Next is the input parameter. Since we are returning parameter which is double, so the return data type should be double, and a suitable name for this method is getParameter. And since all the data inside the code, which is pi and radius, available inside the class, so we don't need any other data to do the calculation, so we don't need any input parameter. After you define these two methods, then you have to include them inside the circle definition that we have defined earlier. Earlier we defined circle with two data members, public, one for pi and one for radius, and two public methods, one for computing the area and one for computing the parameters. This is how we define methods, and now let me show you how to access the methods after we create an object from this class. This is now the definition for circle class, and here we have another class which is for our main class that we are going to create object from the circle class. Like what we did before, the first step is to create an object from the class, and you do this by writing the name of the class followed by a variable which is a reference called C1 equal, and then you write the command new, and this is the command for creating an object, followed by the name of a constructor, which is a special method inside that it is not defined yet, and it will be provided by the system. After this step, now you have an object called C1. Inside it, we have pi, we have radius, and we have two methods. One is called getArea, the other one is called getParameter. Now, if you want to change the radius of the object, you use dot to access the data inside. So you write, since radius is public, simply you can write dot. So you say C1.radius equal 2.3, and now you are changing the radius. You initializing the radius into 2.3. Now suppose I want to compute the area using the object C1. Again, you can use dot to access these methods. Now since the first method getArea is public, you are allowed to use C1 dot. And since getParameter is also public, you are allowed to use C1 dot. So let me show you how the object C1 can call the method getArea by using dot. So this is how to get and print the area. First you write C1 dot, and then you write the name of the method, which is getArea. Here you are calling the method. It means you are going inside the class, do the calculations, and then comes back to your main class. The return value, which is area, will be saved into a variable defined inside this class, also called area, as a double variable. Then you print the result. So now how to access the methods from objects? The same way you access the data by using dot. Now if you want to print the result directly without saving it into a temporary variable, you can just call it directly. For example, if you want to get and print the parameter, there is no need to save it into variable. You can simply print it directly. Here you say print, the parameter is, and see here you are using C1.getParameter. So here you are calling the method getParameter. In fact, when you call this method, you are going inside the class because the object is called C1 and the map for C1 is the class. So you go inside getParameter method, it will do the calculation, and then after returning, we are returning back to print, and it will print the result. So this is how you access the data and methods when you create an object from class. After we define the methods, let me show you how we call the methods from within the object. This is the window for the circle class, and this is the window for the main class. So here we are creating an object from circle class, and we are accessing its data and methods. This is the window for the canvas where we will trace our program by inserting the variables inside it. So let us run the canvas first. So when we run the canvas, this is the first line in our program. In this line, we are creating an object of type C1. So we will continue. After this line, we will see inside the memory that we have a variable called C1, which is a reference. And this is a reference for the object. If I want to see what is inside, we drag it into the canvas. As you notice, it has two data members, pi, which is this one, and radius, which is equal to 0. As well as it has the methods inside, but it is not shown. So this object not only contains data, it contains also methods. So when we return back, this statement C1.radius equal 2.3, in fact, it is changing the radius inside the object into 2.3. Let me show you how. So now see the result. The radius has changed to 2.3. Now we come to calling the method. When you say C1.getArea, now here you are calling a method. So when you call a method, what happens? First, the parameters inside here, which are called actual parameters, are first copied into the formal parameters of the method defined inside the circle. But since we don't have any parameters, so nothing will be copied when we call the method. Simply, we will go inside the method. So now we are inside the method, see? And here this program is suspended now, stopped for the moment until the method gets the result back. And when we do the calculation inside, it is saved into area. If you want to see what is the value of area, you go left, see it is 16 0.619, and then when you click continue, here we have a return, so the value of area will be returned back to the main program. After it is returned, what we are doing, we are saving it into area. So when we continue, so the value of area, see on the left hand side, will be the same value that was sent from the method. So the method computes the area, send it back to the main program, and the main program saved it into area. Now this value is printed, and similarly for the other method, so here we are calling. So since this is a method, so we say we are calling the method getParameter. Again, we don't have any input parameters, so nothing will be copied into the formal parameters for the method because no parameters. But control will be jumped to the method. So we will go inside the method will do the calculations, and the result of the calculations will be returned back. And once this result is returned back in here, it will be taken by the print, and a print will print it on the output screen. So this is what happens when you call a method. Simply you go inside the method, you execute the statements inside the methods. After you finish, when you return back, it will return the result back to the place where you have called the method. And this will terminate our program. In the next step, we will show you how to use constructors for initializing instance variables. Remember that in Java, when you define a variable, first you have to initialize it before you use it, otherwise you will get syntax error. Similarly for objects, when you create an object from a class, then you need to initialize the instance variables in this object, otherwise you will get syntax error if they were not defined with an initial value earlier. So here I'm going to show you two ways to initialize instance variables or data members, one without using constructors, the other one by using a constructor. If we don't want to use constructors, then you have to initialize the instance variables manually. First, you have to create the object. Second step, you initialize the data one by one by using the assignment statement. So radius is the only data member or instance variables inside the class, and this is how you initialize it to 2.3. If it is not already initialized inside the class definition with any initial value, and if you don't initialize it explicitly here, you will get a syntax error. So you need two steps, one for creating the object, the second step initializing the data members or the instance variables. Now if you want to use constructors for initializing instance variables, when you define the object, first is the name of the class. Here this is the name of the class, which is circle, and after new is in fact not the name of the class, it is called a default constructor. So this is not the name of the class, this is a special method that is used to initialize instance variables inside the class, and it is called default, which means that the system will give you this constructor if you did not define one by yourself. So how to use constructors when you want to initialize the data? This is how it is done. Since after a new is the name of the constructor, so we will use the input parameters of this constructor for initializing the data. So we will combine these two steps, we will combine them in one step. In here, in fact, we are creating an object called C1, and at the same time we are calling the constructor and given the constructor 2.3 as an input parameter. How it is done? It will take 2.3 and copy it into the radius which is defined inside the class. So how to define it? Simply similar to how you define a method. And remember, for a method you need a name, return value, input parameter, and the body of the method. Now what makes it so special? That it does not have to return anything. So in the place of returning a value, when you define the method, you just leave it blank. And for the name of the method, it should be exactly the same as the name for the class. So here it is how we define it inside our circle class. To define it, first you write public and you leave the return value blank, followed by the name of the method, which is exactly the same name that you have given to your class, followed by the input parameters, which are the data you want to initialize. Since we are going to initialize only the radius, which is one value, you pass it as a parameter inside this constructor, which is the method. Once the constructor takes it, then it will copy it into inside radius. Of course, here you can put some restrictions by first testing for the new value. If it is negative, then don't allow to initialize the radius to negative number. So you can put if statement here. So you can put any restriction you like for the initialized data that's coming from outside. So this is how we define constructors. Here we are again in JGrasp. So this is on the right hand side, we have the circle definition. As you see, we have included the constructor in addition to the methods and data members. And on the left hand side, we have the test application, the class that will test the circle class. Now here how we create an object, and at the same time, we call the constructor to initialize radius into 2.3. Basically for constructors, they are only called when you create an object. And later you cannot use dot to access them. So they are called automatically when you write new and when you define the object. Let me show you how this is done using the Canvas viewer. Now we are running the Canvas viewer, and as you can see, we start our application here. We will go now here. See what will happen in this step. Two things will happen. First, an object of C1 will be created, which has a radius that is not initialized. See here, the radius is not initialized to any value. And at the same time, automatically the constructor will be called by the system. And 2.3 will be copied into new radius. And this new radius, the constructor will take it into radius. So let me show you how this is done. We will go inside. See how it is called now automatically? And now we are inside the constructor. And if we would like to see what is the value of a new radius, we grab the variable and drag it into the canvas. And at the same time, I would like to see the value of radius inside, so you can grab this as an object inside the class. So this is the radius current value for radius, and this is the current value of pi. They are not initialized yet because, as I said, that the instance variables are created when you initialize them. So let's proceed. What is the value of a new radius? 2.3. It is copied from the main program, which is 2.3. It is copied into new radius. And now when we continue, then the constructor will create first the constant because it's already initialized. And then radius is not initialized yet. So when we next go to the statement, this statement will copy new radius with 2.3 and save it into radius. And see now the value of 2.3 is now saved into radius, and after that the return back will go to the main program. After we finish, then we will have a class, and if I want to see what is the value or what are the values inside C1, I simply grab the object, and as you see, the value of pi, it was already initialized when we created the object, and 2.3 was initialized by using the constructor. By continuing, then we are simply calling the methods for the object to compute the area and compute the parameters. So what constructors are used for? They are used for initializing the data members or the instance variables inside the class when we create an object. Now sometimes you don't want to initialize the instance variables with invalid data. For example, imagine here you put minus 2.3, and you know that for radius minus is not acceptable, so the constructor will not check for that. It will simply take it as an input parameter from here and will save it into radius. So how to prevent invalid data to be initialized for instance variables? Simply you go to the constructor, and here you can check for the input that's coming from outside. So you can say if new radius is less than 0, so that means it is negative. Then what you have to do here, we will do two things. First, we will print a message, system.out.println, and by printing the new value and saying after that this new value is an invalid radius. This is the first thing we should do if we have an invalid data. The second thing, we will initialize radius into 0 so that it can be created inside the class. Since we have two statements, then we need to surrounding by curly braces or curly brackets. Otherwise, if this is not the case, then otherwise we will simply copy the input parameter that's coming from outside and we save it into radius. Let us test our program, and here we have minus 2.3. So when we trace the program by the canvas, here we have a problem, println a new radius. Yes, I have to put capital letter R. Let's run the canvas again. And so we will just continue from there. So we will go inside and we will see that the value of a new radius, see, it is negative. And if it is negative, then we should not accept it, but the constructor will check for it. And the constructor have seen that it is negative. So it will go inside, it will print an invalid. See, it says minus 2.3 is an invalid radius. At the same time, it will initialize radius to 0. Now let us try and put a positive value instead of negative value, and here we will just put 2.3 and run it again. Now when we run it again, we will see that we will go inside, it will check for the input parameter. See, it is positive, so it will move it into radius as a valid data. So not only it will initialize the data by copying, it will also check for validity whenever we want to initialize the instance variables. After using constructors for initializing the instance variables, let us show you now the difference between public and private instance variables. These are called modifiers, data members modifiers. When you write public, it means the data can be accessed from outside when you create the object using dot. And here is an example that when you say public double radius, that means you can access it from inside the class, which is here inside methods or constructors, as well as outside the object by mentioning its name. So this is an example in a different class. This line creates the object, and as you see, does not have a constructor, because if we have this is a default constructor. Otherwise, we would initialize it directly. And this is how to access the data directly from outside. So this is inside the class, and this is another class. You are creating an object from this class. So we say you are accessing the data from outside. Since the data is public, then it is allowed to use dot to access the data for reading and writing. And here, in fact, we are writing. So you are saving 2.3 into radius. So you are writing into radius is allowed. And also if you are reading, for example, printing, so C1.radius here, in fact, you are reading the value of radius inside circle, also is allowed because the data is public. Now, when you change the definition into private, so the specified or the modifier for the data member has changed from public to private. Now, when you say private, that means it should not be exposed outside. So it should be used only inside as a private data member. So it can be accessed only inside the object, inside constructors, inside methods you defined, inside the class. So if you try to do this outside the class, when you create an object, either for writing or reading, you will get syntax error. So C1.radius equal 2.3 is not allowed. You are trying to change the value of radius, and since it is a private, this is not allowed. Earlier it was allowed because it was public. Similarly for reading, not only for writing, also for reading. So that means it will be hidden inside the class. When you create an object, you cannot see it outside the object. Now the question is, if you define the data public, then you can change it or you can read it. Now if you define it as, for example, private, then the question is how to change it if we wish, and how to read the value if we wish. And this is what comes for the next step, is how to access a private instance variables, either for reading or writing. This will give you control for both reading and writing. When you open it for public, then you don't have control for whether to allow reading or to allow writing. Both will be allowed. But if you define the data private, then you have the control to allow, for example, reading but don't allow writing, or you allow writing but don't allow reading, which is logically and it doesn't make sense, but it is possible. So let me show you for the next step how to access the data if it is defined as private. To access private instance variables, either for reading or writing, we use special methods that are called getters and setters. So what are these methods? For reading, as an example, if you want to read the value of an instance variables, you define a variable that is called getter. And this method is used to read or get the value of a private data members. Another name for the method getter, it's called accessor. So whenever we say write a method for accessor, you should know that it is for reading. The other method for writing or changing or setting the data of an instance variables, it is called setter, which coming from the word set. And this is used to write or set a new value to a private data member. Another name for this method is called a mutator. So mutator is the method responsible for changing the value of an instance variables. Since these are methods, then we need to define them with names, retain values, with sometimes input parameters, and the body, which is the responsible for reading and writing. Let us see the definition first for getter, and then we will show you the definition for setter. This is our class, and we have two private data members. One is pi, the other one is radius. Remember, they are private, so we cannot access them from outside. We cannot use dot. Now we need to write two methods for demonstration, one for reading the value of radius and one for writing a value into radius. The getter is defined as follows. It should be public, and the return value depends on the data type of this instance variables. If it is double, you write double. If it is char, you write char. If it is a string, because it is going to be returned. And now, what is the name that is used for these methods? It is a convention by Java programmers, is that you precede the variable name or the instance variable name by the word get, and you uppercase the first initial letter of the variable name. So when we have radius, then the getter will be get radius. If we have a private variable called age, then the name of the getter will be get age, and etc. And inside, you write return the instance variable, which is radius. So this is how you define your getter method. So it's a standard definition for the private data members. Now for getters, since we are going to set the value, so we don't return any value from this method. So the return value will be method, and similarly, with the name of the method will be the name of the variable or the instance variables preceded by set. So since the name is radius, so the name of this setter will be set radius. Since it is going to change the value of the private data, then you need to provide the new value through the parameter. Since the variable radius, which is the instance variable, is double, so the input parameter should be double. If it is char, then the input parameter should be char. So the purpose of this set radius is just simply taking the input and save it into radius. Also, you can test for the input like what we have done for the constructor. So don't allow the setter to set an invalid data to the data member. So before you set the value of a new radius into radius, here you can put if statement by testing for a new radius. If it is negative, then simply don't change the radius. And this is not a constructor. For the constructor, you are initializing the variable. So if it is invalid, initialize it to 0. But in here, if it is not valid, just leave the old value inside the object as it is. So you write if new radius less than 0, just to print a message and don't change the radius. Otherwise, else you say new radius equal to radius. So this is the main purpose of getters and setters, to read and set private instance variables. So how to use these methods for reading and writing? This is our circle class. It has two private data. One is double radius, the other one is double pi. Now for the pi, we will keep it private inside. We will not allow to be accessed from outside because it is used internally inside the class. But for radius, we will allow the user, which is another class, when we create an object from this class, to change the radius by using the method setter, and to read the value of radius by using a setter. So this is how you define the getter. Since the radius is double, so you write public double, and the name will be get radius. R is capital letter, and simply inside you write return radius, because this is the return value you want to return it back. And for set radius, the new value is tested here. If it is negative, then the value of radius is unchanged, but only a message will be printed that it is invalid. Otherwise, it will change the radius by this new radius. And since the instance variable double is the radius is double, so the input parameter also should be double. This is our main class. So first we create an object from circle, and we are using the constructor. So radius will be equal to 2.3. Next, now we would like to change the radius by the value 5.7. Remember that it is not allowed to use dot. So you cannot say C1 dot radius equal 5.7. But we have a method that is responsible for this. So simply give it 5.7, and this 5.7 will go into new radius, and the method will test for it. Since it is not negative, so it will copy it into radius, so it will change radius from 2.3 into 5.7, and this is writing into the variable. Now suppose I would like to print the value of radius. Since it is a private, then I cannot use C1.radius. So I'm going to use the method get, and this method responsible for returning the value of radius from outside the class. So here we say C1.getRadius. So we will go inside this method, and this method will return radius back, and the print will take this return value and print it outside. So this is for writing, and this is for reading. Now if you don't want to change the value of radius after you create the object, simply do not define set radius. Only get radius if you want to show what is the current radius inside the object. After learning the 6 steps, let us put these steps into action by the following example. This example is for building a class. In part 1, we are going to write the class specification, and in part 2, which is in the next page, we are going to show you how to create an object from this class. The class consists of data and methods. For the data, it could be private or public, and for the methods, consist of a constructor, getter and setter, and an ordinary method. Let us see what is the class specification for this example. First, it says we have to create a class called building. So this is the name of the class that has 3 private data members. So we know that we have 3 data members and all of them are private. The first one is a string for name. The second one is an integer for number of flats of this building. And the third one will be an integer for rooms per flat. Let us first write the class definition for this part, and we will continue for the other parts. So here we are in JGrass. It says create a class called building. So we start typing public class, and the name we are going to call it building. We open curly braces or brackets to start including the specifications of the class. It says it has 3 private data members. So the first one is a string, so private string, and we will call it name. And the second one is number of flats, so it will be private int flats. And the third one will be also integer, so we can include both of them in one definition, and it is going to be called rooms per flat. Rooms per flat. Let us save it as building. So it's called building.java, and we are going to include it in shapes classes project. Let's go back and see the rest of the parts. In the second part, we need to create a constructor that accepts. When it says accepts, it means it has an input parameters. A constructor that accepts only the name of the building. And where is the name of the building in the data members? So this is the name of the building. So it accepts only one input, which is the name of the building, as an input parameter. Now the constructor sets the data member name to the input parameter. So we will give it an input parameter, and it will initialize this name by this input parameter. And also it will initialize flats and rooms per flat to 0. So flats and rooms per flat will be initialized to 0 by this constructor. Let us go and write the constructor in JGrasp. Now we are in JGrasp. So remember that for a constructor, we write first public, and for the return value, you specify nothing, just leave it blank. And the name of the constructor should be exactly the same as the name of the building. So I will copy it, Control C, and then I will paste it Control V as the name of the constructor. Now the question here, it says write a constructor that accepts only the name of the building as an input parameter. So we know that the name is a string. So here we write string, and I'm going to call this input parameter new name as an input to the constructor. And then we write the curly brackets for the begin and end of the constructor. Now it says here that the constructor sets the data member name, and see, this is the data member name. Now this constructor will set the data member name to the input parameter. Where's the input parameter? This is the input parameter. So when we say that name is set to the input parameter, so that means here we write name equal new name. So here we are setting the input parameter to the data member name. And in the rest of the question, it says also it initializes a flat, which is this one, to 0. So we say flats equal 0. And also it initializes rooms per flat, Control C, it will also initialize it to 0. So this is what the constructor is doing. It takes an input parameter as a string for the new name, and it will copy it into name, which is the data member inside the class. And it initializes the two integers, flats and rooms per flat, to 0. The third part, it is asking to provide an accessor and a mutator methods only for the name data member. So it's not required to write accessor, getter, and mutator for all data members, only for one. So don't waste your time and provide getter and setter for the other data members. Now we are back to JGrasp, and now we need to write an accessor, which is get, and mutator methods only for the name data member. So we will first write the getter, and remember that for the getter it will be public, and since the getter is going to get the name and the name is defined as a string, then we write here string, and the name we are going to use for this getter is get name, and it should not have any input parameter. And inside simply you write return name, which is the name of the data member inside the class. Now for the mutator, it will be public void, and the name will be set name, because this is going to be for the data member name. And since it's going to set a new value for name, then we have to take the new value as input parameter. So we will have a string, and we are going to call it a new string, sorry, a new name. And then we will make this method to set the value of name by the input parameter, which is a new name. So it works exactly the same way as the constructor. when it initialized the data member name. So this is the answer for part C, the getter and setter for the data member name. For the next part, which is part D, it is required to provide a method, set building details, that sets both flats and rooms per flat data members from input parameters. You know that for a method, we should have return value, we should have a name, we should have input parameters, and a code inside. It is given here that the name of the method is set building details. When it says sets it means change or write. Its responsible is to change the values of the data members, flats and rooms per flat. From where? From the input parameters. So the input parameters will be the new values received by the parameters, and the method will save them into flats and rooms per flat. Any of the input parameters is negative, leave its corresponding data member unchanged. So before we try to set these values, we need to test for their values for validity. If any of them is negative, then we will leave its corresponding data member unchanged. Here we are in JGraphs for part D. As you know, for methods, we write public, and then for the return value, we don't know now yet. We need to decide later. And then we need a name, and from the question, we can get the name. If the question did not determine a name, then you have to give it a name by yourself. And then it says from input parameters. So there are input parameters in the code. Again, I will leave it now empty. We will fill it just in a moment. And the code for the method will be surrounded by curly braces or curly brackets. It says that it sets both flats and rooms per flat from input parameters. Since we have two data members, so we need two input, one for the flats, I'm going to call it a new flats, and the other one also integer, I'm going to call it a new rooms per flat. And these values will be received by the method, and the method should simply save it into the corresponding data member. So new flats should go to flats equal to new flats, and rooms per flat should be set by new rooms per flat. But the question says here, it says any of the input parameters is negative, then we need to leave its corresponding data member unchanged. This can be done by the following. Before we set the value of a flats, we need to change the value that's coming from the input parameter. So if new flats is negative, which is less than 0, then here simply we will just print a message, system.out.println, by saying that the value you have give us, which is a new flats, is an invalid flats. And then we close the system.out.print. Otherwise, we will save the input parameter into the data member. Similarly, for the new value for new rooms per flat, we say if new rooms per flat is negative, then again we will print a message by saying system.out.println, and we'll print the new value, the new rooms per flats, followed by a message by saying invalid rooms per flat. Otherwise, else, we will move the input parameter into the data member rooms per flat. And this will complete the solution, but before we proceed, we would like to see what is the return value. As you notice, all the statements inside do not have to return a calculation or do not have to return something. All what it does is just change the values for flats and rooms per flat. And at the end, the method should not return anything, so the return value will be void. In the next part, we need to define a method called calculate capacity, which calculates and returns the capacity as double of the building. Whenever there is a calculation that should be done by a method, then we must return the result of this calculation. Now, how to compute the capacity of the building? We are going to compute the capacity of the building by using this formula. So capacity is equal to flats multiplied by rooms per flat divided by factor. Notice that the flats is a data member inside the class. Rooms per flat is also a data member inside the class, and factor is a constant. So let's go to JGrasp and implement this method. So we start typing public and the return value as mentioned double, and the name of the method will be calculate capacity. So simply copy it and paste it, and then we need to see whether we need input parameter or not. So now we surround the code for the method by curly brackets. We have a calculation like what we did before in circle when computing the area. We define a local variable and we put the result of the calculation in this variable. So it will be flats multiplied by rooms per flat divided by the constant 0.75. And then we return the value of this local variable. Now, by looking at the code inside, let us identify the variables we are using. We are using flats, which is a local data member inside the class, C flats, and rooms per flat is also a data member, and 0.75 is a constant, so this method does not need any other variable, so therefore we don't need any input parameter. Notice here we are saving the result into a variable and then we are returning this variable. We can do this in one time or one shot. Simply take the equation and return it directly. So there is no need to save it into a variable and then return this variable. You can just simply write return and put the equation directly after return. And this will give us the solution for part E. Now let's turn to the next page. In the next page, we have a remaining part to define a method called display building details to display on the screen all the building's details. So this is the name of the method, and since all what it does is just a printing, so therefore there is no return value and the return value will be void. Let us see what this method is printing. First, it is printing a title. You can just simply use println between double quotation name, but Andalus is the value that is stored inside the data member name. And flat is a title. At 20 is the data value stored inside the flats. Rooms is a title, and 3 is the number of rooms per flat saved or stored into the data member rooms per flat. And capacity is the result or the return value of the method calculate capacity. So we are going to call a method which is defined internally to give us the value for the capacity of the building. Let us see how we can do this by JGrasp. So here we are going to define the method. So simply we say public, and remember that this method is only printing, so the return value is void, and the name of the method is already mentioned in the question. So we will copy it and paste it, and then we will see whether it needs input parameters or not, and the code inside will be surrounded by curly braces. Now this is what we want to print on the screen. This part. So let me just copy it, and here we write system.out.println, and since this is a title which is name, so we will surround it by double quotation, but Andalus should be taken from the data member name, and this is going to be the first line printed by this method. Now for the second line, again we are going to use print system.out.println, and since flat is a title, so it will be surrounded by double quotation followed by the value of the data member flats. followed by a title, comma, with rooms, and then 3 is coming from rooms per flat, followed by a title with comma, capacity, and now here we need to call the method that computes the capacity, which is defined here. So all what we do is just simply call the method internally to do the calculation for us. Here, since we are defining the method inside the class, so there is no need to use dot. What I mean is that if you define a method inside a class and you want to use it in a different method, there is no need to write dot because you are already inside the class. So this is why this method display building, when it needs calculate capacity, you just simply call it without using dot. But if you are creating an object from this class and to call any of these methods from outside, then you have to call the name of the object followed by dot followed by the name of the method, and we say we are calling the method from outside, but if you are calling the method from inside, you don't need to specify dot. Finally, let us look at the variables we are using inside the method. We are using name, which is a data member inside the class, flats, a data member inside the class, and rooms per flat is a data member inside the class, and this is a method. So therefore this method does not need any input parameters, so therefore we leave the input parameter empty without any input parameters or arguments. Next is part 2. So for part 1 we have defined the class. Now in part 2 we need to define another class for the main program to create objects from part 1 class. So let us see what is required in this part. It says write a Java application to do the following. In part A it says create an object called B1, so this is the name of the object, from the class building, and initialize its name to a while. Remember that we have created a constructor, so whenever it says initialize, it means you need to use the constructor. So you need to define a variable or a reference B1 for the object from the class building. Let us do this. So now this is the definition for the class building, and it is in a file called building, and this is another class which is different file for the main program. So we will write public class and we will call it building test app, and then we start and end the definition for the class, and inside we have public static void main string args, and this is our main method for our main program. So in part A it says create an object, so I will copy the comment so that we can follow it here. So we need to create an object, and to create an object from this class we write the name of the class and the name of the variable B1 equal new, and then we will use the constructor building and we will put a while as an input parameter. So this will finish part A. Now in part B we need to set the number of flats of B1 to 12 and the number of rooms per flat to 3. Remember that for the building we have 3 data members: name, flats, rooms per flat. So we need to set those values 12 and 3 for these corresponding data members. Let us see how to do this by using JGrasp. Now to set these values, notice now inside building, flats and rooms per flat are private. So you cannot just simply say B1 dot flats equal to 12. You are going to get syntax error. Why? Because flats is not defined as public, it is defined as private. So how to change its value? We need to change the values of a private data by using methods. So let us see which method we need to use to change the values for flats and rooms per flat. So when we go down, see here this method. Now this method, set building details, its job is to change the values of flats and change the values of rooms per flat. So simply we are going to call this method to change the values of flats and rooms per flat according to part B. So how to do this? First we have to call the name of the object B1 dot, and then we write the name of the method set building details, and between the round brackets we put the parameters. 12 will be for flats, for the number of flats, and 3 will be rooms per flat as an input parameters. So 12 and 3 are called actual parameters, and in here new flats and new rooms per flats are called formal parameters. So when we call the method, when the method is called, 12 will be copied into new flats and 3 will be copied into a newsroom per flat. Finally, in part C, we need to display the building details for B1. When we say display the building details, it means the name, number of flats, and number of rooms per flat. Remember that we cannot access the data directly, so we need to use a method to display this information. Let us go to JGrasp and see this method that displays the building details. By looking at the methods inside, see what methods we have. We have calculate capacity, and here we have display building details. So we can use this method to display the details of the building. So for part C, display the building details for B1, and to do this you write B1 dot display, which is the name of the method here, display building details, and the method will display all the details of the building. And this will complete the implementation of the program, and after that we need to run it and see that it runs without any problems. Now to run the program we have to save first the second class. We did not save it, so save, and the name will be building test app, and we're going to save it in shapes classes project. And also here we need to save the other files. So we have two files, one for the class, let's go to the beginning, which is called building, and one for the main program. So let us run the program first. Let us compile, looking for errors. So we found an error in a class, and it is in the print. It says new rooms per flats is not defined. Yes, not defined because I put extra S. And let's run it again, compile. Again here we have another problem. Rooms, rooms per flat. Compile again. So we don't have any errors. Let's go for the main class. Again we don't have any errors. We will run it and we will see the result here, and notice that it is printing the name Awal and the flat 12, rooms 3, and capacity 48.0. We can trace the program by using the Canvas viewer. So we will run the Canvas viewer, and we will put the window for the Canvas viewer in one side. So now we are in here. So we will go inside the class by calling this method. So now we jumped into the class calling the constructor. So this is the constructor. It will initialize names, flats, and rooms per flat, and then we'll go out to the main program. If I want to see the details of B1, simply we drag it. We drag the variable inside, and this is what we have at the moment inside the object B1. Next, we will call a method setBuildings by giving it 12 and 3 as input parameters. So now we are inside the class. See, we are inside setBuildings details, so we have jumped to the other class. we are saving, see, new flats is equal to 3. Sorry, new flats is a 12. If I want to see the value, I can drag their values into the canvas. So the input parameters, the new flats is a 12, new rooms per flat is a 3, and these will be copied into flats and rooms per flat. See, the number of flats has changed to 12 and rooms per flat has changed to 3, and now we are returning back to the main program. Again, we are calling a method display buildings details inside the class. So we will go inside the object or inside the class. It will print, as you see, it is printing here a wall, and then we are calling again calculate capacity. See, it will jump to calculate capacity and comes back and display the result, which is 48.0. And this completes the running for the program and completes the implementation of our program for the class building. By this time, we have finished today's lesson, the quick review for classes. Good luck, and we wish you the best.